Lesson 3.4, using the quadratic formula. How do you solve quadratic equations using the quadratic formula? So these are two problems that we've done in a previous lesson. I want to know what about this problem guaranteed I was only going to get one answer. And what about this problem guaranteed my answers were going to have i's in it? Well, the only way to get an I is if I was trying to take the square root of a negative number. So I'm wondering if the square root is telling me that is why I only got one answer. The only reason why I got one answer is because I was adding and subtracting 0. That's because I was taking the square root of 0. Using that, how did I get two answers here? I got two answers in this problem, and they don't have i's because I still had a square root, and the square root was not going to be a negative number. So these helped me figure out how many answers I was going to have. So we just looked at some problems, and we were looking at the quadratic formula in 3 problems. And we were specifically looking at what happened in our square root. So I know that if I was taking the square root of a negative number, that I was going to get two answers, but they were two imaginary answers. If I was taking the square root of 0, I was only going to get one real answer. And if I was taking the square root of a positive number, I was going to get two real answers. And that's what it says up here. So if the inside of my square root was bigger than 0, if it was positive, then I was going to get two real solutions. If the inside of my square root equaled exactly 0, I was going to get one real solution. If the inside of my square root was smaller than 0, meaning it was a negative number, then I was getting two imaginary solutions. And this is what that would look like visually. There are two intercepts, but we can't see them because they're imaginary. It's only one, meaning the vertex was the one that was on the axis, was the one on the x-axis. Or there were two solutions, and we could see that it visibly crossed it twice. So using the number that's on the inside of the square root, you can figure out how many answers you're supposed to find. So I have 3 problems here. They want us to find the discriminant. The discriminant is what you are finding to tell us how many solutions. This was the b squared minus 4ac part, the part inside of the square root that will tell us how many solutions we'll have. So if I'm looking at the b squared minus 4ac, the part inside the square root, my a was 1, my b was a negative 6, and my c was a 10. What did I end up having inside the square root? I need b squared, so I have a negative 6 squared, minus 4 times my a was a 1, my c was a 10. So I have this entire quantity to the second power, so I have 36 minus 40. 36 minus 40 is a negative 4. This is supposed to be the inside of the square root. If this was inside my square root, you're going to be asking yourself, what happened if I actually took the square root of this number? You would end up getting two imaginary solutions. Let's look at the next one. I need to find my b squared minus 4ac, the inside of the square root. What would it have been? So my ABCs, my a is a 1, my b is a negative 6, my c is a 9. So I have b squared minus 4 times my a times my c. Negative 6 to the second power is 36. This is 36 minus 36, which is a 0. This is supposed to be the inside of the square root. So if this was the inside of the square root, what would happen if I took the square root of 0? I would end up only getting one real solution, meaning he only crossed the one axis one time. Let's look at the last one. I need to figure out what would have been inside my square root. The a is 1, the b is a negative 6, the c is an 8. So I have my b squared, which is a negative 6, minus 4 times my a is a 1, my c is an 8. Negative 6 to the second power is 36 minus 32. 36 minus 32 is 4. So you're asking yourself, this is the inside of the square root. So if that is the inside of the square root, what happens when you take the square root of 4? I get 2 answers. So I must then get 2 real solutions. So by using the discriminant, you can figure out how many x-intercepts you're supposed to have.